In this video, we're going to be proving triangles congruent by angle side angle, angle side, and the hypotenuse leg theorem. We haven't talked about the hypotenuse leg theorem yet, so here it is. Remember, hypotenuses are segments that are found only in right triangles. So when we see the hypotenuse leg theorem, that tells you automatically that we are dealing with right triangles only. So the hypotenuse leg theorem says that if we have two right triangles, you know they're right triangles because you have those boxes for to show us that those are right angles, and we know that the hypotenuse is congruent and one of the legs is congruent. So if we have a situation like this, right angle is not in between the two sides that we are talking about. The right angle is not included. It's not the included angle. If it were, then we would have side angle side instead. So we have SSA, like we have a side, and then the angle. And we said before that that wasn't a theorem. If we have a right triangle, then SSA does exist, but instead of saying SSA and confusing ourselves, we call it the hypotenuse leg theorem. So in this instance, the triangles are congruent. Now, when we do these proofs down here, what I suggest you do is that you pause the video and then you try to do these on your own. Then once you're done, unpause it, see my answer. If you don't get the same answer I do, then listen to my explanation. If you do get my answer and it all made sense, then you really don't need to hear the explanation and you can move on to the next one. So the first proof is we're trying to prove that triangle GCA is congruent to triangle BAC. So remember, that's going to go at the end here. So let's fill that in. And we're also going to fill in what's given. Angle G is congruent to angle B. And CB is parallel to GA. That's given. So now those things are marked for us already. What I'm going to look at is now angle ACB is congruent to angle CAG. Let's see. Why can we say that's true? Let's look at that angle. ACB is this angle right here, and angle CAG is this angle right here. We are told that these two lines are parallel and that this, let's use a different color. Here is our transversal. So we have two parallel lines. If we look in between them, that's the interior of those parallel lines. And the two angles that I marked are alternate interior angles. One angle is on the left side of the transversal, the other angle is on the right side of the transversal, and they're both on the inside of the parallel lines. So the reason why we can say those two angles are congruent is because the alternate interior angles are congruent. Now, the next statement is blank, but we know the reasoning is the reflexive POC. So when we see reflexive POC, we're looking for a shared side. Well, I'm going to erase the parallel lines and transversals for a minute. And we see, oh, CA and CA, that's in both triangles. That's congruent to itself. So we have CA is congruent to AC. You may say, well, why did he change the lettering? Well, look at in the left triangle, the angle that is marked with two angle markings touches point A, but in the top triangle, the one on the right, the angle mark that's congruent, the one here, angle C, that's touching our congruent side. So that's why I changed it. So now, why can we say those two triangles are congruent? Well, we have an angle, another angle, and then the side. And then the other triangle, we have angle, angle, and that side. So these two triangles are congruent by angle, angle, side. All right, now if we look at the next one, and sometimes I like to draw the triangles separately when they're overlapping. In this one, there was just a shared side. Here, the two triangles are overlapping, so if it does make things easier for you, you can draw them where they don't overlap, because when they overlap and you are starting to mark things, it can be confusing on what thing you're actually marking. So I'm just going to draw. They don't have to be perfect, just close enough. Oops, let's do a capital M. Let's be consistent. And L. Okay, so now let's go and do our proof. We are given that angle JMN is congruent to angle LNM, and we are given that angle JNM is congruent to angle LMN. And those are given. So let's go and mark those real quick, because there's a lot of N and M's in there that can be very confusing and easy to mistake. So JNM, that's this angle here, is congruent to angle LMN. That's this angle right here. And then we have in purple JMN, that's this angle right here, is congruent to angle LNM, this angle here. Okay, so we have two sets of congruent angles. Now let's look at statement 2. NM is congruent to MN. Well, that's a shared side. You can see that in our overlapping triangles that it's shared, but it might be easier to see it in the separated triangles where these two sides are the same thing. So that is the reflexive property of congruence. And like always, our proof, what we're trying to prove, goes at the end. Triangle MJN is congruent to triangle NLM. And then why can we say that? Well, we can say that because we have angle, side, angle. The side that's congruent is in between the two congruent angles. So this is angle, side, angle. All right, let's look at the next one. And you see that this picture is kind of a mess. You have a lot of triangles here. So which one are we actually talking about? So we're talking about triangle AED and triangle BEC. So let's redraw those separately down here to kind of give us a better idea of what we're dealing with. So we have AED and triangle BEC. Okay, so that's what we're trying to prove, so let's put that at the end. Triangle AED is congruent to triangle BEC. And what we're given is that AE is congruent to BE, and that angle ADE is congruent to angle BCE. So let's mark that up. So AE and BE are congruent. So AE and BE are congruent. We have angle ADE, this angle is congruent to angle BCE, this angle here. And that's our given. Now we have statement 2, which is blank, but the reasoning is vertical angles are congruent. Well, when I drew these separately, it may be hard to see our congruent angles. So if we look at our picture up here, we should be able to tell that these two angles at E are congruent because we have AC and BD that intersect, and that forms two sets of vertical angles which are congruent. So we translate that down to our separated picture, and we have angle AED is congruent to angle BEC because those are the vertical angles. So then we look at the two triangles and say, how do we know that these are congruent? Which of the five theorems do we have? This is angle, angle, side. Angle, angle, side. Now, the fourth one, you'll notice that there's a lot more. We have 5 of these things now. So let's look at our given. Remember, this symbol here, that upside down T, that symbol means perpendicular. Perpendicular, which means we'll have a right angle when those lines form. So let's write down our given stuff. ST is perpendicular to TW. VW is perpendicular to WT. And then we also have angle VTW is congruent to angle SWT. Okay, so now I'm going to mark the angle first that we're told is congruent. VTW is this angle here on the right side, and SWT is this angle here. So we have that taken care of. Let's write down given. Now, when we have perpendicular lines, that means that we have right angles. So if ST and TW are perpendicular, that means this angle here is 90 degrees, where line ST and TW intersect. And where VW and TW intersect, that's also a right angle. So why can we say that those two angles are right angles here, STW and VWT? Well, that's because we have perpendicular lines. So our reasoning would be perpendicular lines form right angles. Okay, then the next statement, we don't know what it is, but the reasoning is right angles are congruent. Well, we just got done saying that those two angles are right angles, so that means they are congruent. And the reasoning is right angles are congruent. Now we have a blank for statement 4 and for reason number 4. Again, I'm looking at this picture and I see that TW is a shared side. So this has got to be congruent to itself. So TW is congruent to WT, and that's the reflexive property of congruence. And the reason why we had to flip the order is because looking on the left triangle, angle T is the right angle. If we look at the right triangle, W is the right angle. So we couldn't say TW is congruent to TW. And then the last statement, of course, is going to be our triangle STW is congruent to triangle VWT. And the reason for that, well, we only have one congruent side, and it is included or in between the two sets of congruent angles. So this will be angle, side, angle. All right, now the last proof. All right, let's go with our given. YW is perpendicular to XZ, and XY is congruent to ZY. That's our given. And what we're trying to prove is triangle XYW is congruent to triangle ZYW. Okay, so then let's mark up our picture. If ZW is perpendicular to XZ, if those two lines are perpendicular, that means we'll have a right angle here and there. That's what happens when you get perpendicular lines. You have right angles. We also have XY and ZY congruent. So let's mark that, XY and ZY congruent. All right. So we kind of already gave away the reason for number 2. Angle XWY and angle ZWY are right angles, and that's because, again, perpendicular lines form right angles. And then right angles are congruent is the reason for statement number 3. So that means statement number 3 must be that these two angles that we just talked about are congruent. Now, I see that WY is a shared side. So WY is congruent to WY. And you may be saying, well, why did you not switch them like you did in the previous problem? Well, look at where the right angle is. If we look at that top triangle, the right angle is at angle W, right here. And if you look at the bottom triangle, the right angle is at angle W as well. So that's telling us that we don't need to switch them. So now how do we say that these two triangles are congruent? Well, we have two sides. Oh, I really need to put 2 tick marks here because WY is not congruent to XY or ZY. So we have 2 pairs of congruent sides and we have a congruent angle, the right angle there. And you may say, well, that's got to be side angle side because we have 2 sides. That's the only one that only has 2 sides. However, that angle that is congruent, angle W, is not in between the 2 congruent sides. So that is not good. That means we're not going to have side angle side. Since angle W is a right angle, we know that these triangles are right triangles, so we can use the hypotenuse leg theorem. So these 2 triangles are congruent by the hypotenuse leg theorem, where we have the hypotenuse and one leg in a right triangle is congruent to the hypotenuse and a leg in another right triangle. That means the 2 triangles are congruent. So I hope that this video was a good proof practice exercise, and it would hopefully get you more comfortable with looking at proofs and looking at things like shared sides and alternate interior angles, vertical angles. Those are things that you're going to have to look for. So thank you for watching. Make sure you like this video and subscribe.